All right. So 7.1 starts dealing with enlargements and scale diagrams. A diagram that is in an enlargement or a reduction of another diagram is called a scale diagram. So we've all seen this before, especially when we take photos and we make it bigger or we make it smaller. Does everybody remember, like, especially on a computer, I don't know about on a phone, but if you take the corners of the picture and then drag it, it will take the length and the width at the same ratio. But if you just say, for instance, drag the width or the bottom part of it down, you make these like short, stubby people or whatever's in the picture. So this is why scale diagrams are important, because what you're doing is you're doing both dimensions to the same amount. So the scale factor is the relationship between the matching lengths on the two diagrams. So here's a big formula. You may want to put this somewhere easily accessible. So the scale factor is equal to the enlargement or the reduction length divided by the actual or the original length. I'll even put this in red, in a box. And the thing you have to remember is the units need to be the same. Units must be the same. So if you do some questions and you end up getting it wrong, check to see if your units are the same. For instance, if you have something in inches and centimeters, you can't find the scale factor unless they're the same. If you have meters and centimeters, you'd have to convert it to either centimeters or meters to be able to calculate it. So in science class, you've seen a triangle before. I'll just put it over here. And you can use the same type of method that, you know, the DVT triangle. And you can put scale factor here. You can have your actual or your original here. And then your enlargement or your reduction here. So then you can see that scale factor is enlargement or reduction divided by actual, because if it's not on the same level, that's a divide. If it's on the same level, you multiply. Okay, so we're going to do our first question here. Here is a scale diagram of a pin. The actual length is 13 millimeters. Notice the units are in millimeters, which means I need to measure it in millimeters. So I'm going to get my ruler. You'll need a ruler yourself. I don't know where my ruler went. Let me just find it. That must never popped up here. There it is. Okay. So I'm going to actually measure this. And I think when you measure it, now this is a photocopy, so it's not measured very well. But I'm going to measure it for you. Somebody did it in class, and they measured it to be 4.5 centimeters from here to here. So here's the problem. This is in millimeters. This is in centimeters. So does anybody know how to convert millimeters to centimeters or centimeters to millimeters? Well, the centimeters is the bigger part. This is a base 10 system. So somewhere we learned that we just move the decimal place once. So this would be the same thing as 45 millimeters. So if I want to calculate the scale factor is equal to the enlargement over the actual. It says the actual was 13 millimeters. My measured amount was 45 millimeters. Notice that my millimeters will divide and cancel. So that's how I know that I have the right thing going. And when I divide, I get roughly so you get 3.46 blah, 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 blah. So this is roughly 3.5 times bigger. Okay, so more than likely you'll be rounding to the nearest tenth. If it's a repeated decimal, you can just put the bar to indicate that. But yeah, so our scale factor is 3.5. So let's do the next question. We're supposed to find the scale factor again. So here is an ant. So if I take my ruler and I measure this, I get that this is 3.8 centimeters, which converts to 38 millimeters. Remember, you just move the decimal place over. So my scale factor is equal to the enlargement, which is 38 millimeters, divided by, it says the actual length is 6 millimeters. So that's going to go here. Notice my units cancel, and this is roughly 6.3 repeating. We're going to do this again. One more example, and then we're going to discuss what enlargement scale factors have a characteristic of. So if they ever give you that it's measured in squares, don't take a ruler, just measure the squares. So does everybody see this is 3 squares, this is 2 squares, this is 9 squares, this is 6 squares. Make sure you're comparing the same dimensions to the same dimensions, meaning length to length and width to width. We refer to length as the longer side. So if I take the scale factor and I take the original is on the bottom, so the original length was 3, my enlargement length was 9, 9 divided by 3 is 3. And just to prove to you that this is a scale factor, that means the width should have the same scale factor. So I'll calculate that again. The width of the original was 2. The width of the enlargement was 6. 6 divided by 2 is 3. Notice they're the same, and that should be the case. So if you don't know which dimension you should be using, it doesn't matter. Just make sure you're using the length compared to the other length or the width compared to the other width. So this leads us to what did we notice about all these scale factors? 3.5, 6.3, and 3. Well, here is the key here. Enlargement scale factor is always, always, always greater than 1. Not equal to 1, greater than 1. So put stars all around that. That is a key concept here. When you figure it out and you know it's an enlargement and you don't get a scale factor that's greater than 1, then you know you did something wrong. Okay. So next up, to find the dimensions of a scale diagram, you multiply each length on the original diagram by the scale factor. Remember our triangle here? Scale factor, original, enlargement. Okay, so do you see that to figure out the enlargement, we're going to multiply because they're on the same level? Remember doing this in science? Okay, so here is a cylinder, and it's to be enlarged by a scale factor of 5/2. So it's giving you the scale factor. Find the dimensions of the enlargement. So this is the height. This is the diameter. So if I take the scale factor, multiply it by the original, I will get the enlargement. So if I take the height, the new height will be, or I'll say the enlargement height is 5 centimeters. I'm timesing it by the scale factor of 5/2. So I'm going to multiply those together. What do I get? I get so many centimeters. I get 12.5 centimeters. So it went from 5, it got enlarged, and now the height is 12.5. So now we're going to do the enlargement diameter. Again, it started off to be 2 centimeters. My scale factor is 5/2. I multiply that together, and I get centimeters. All right, so suppose you draw a scale diagram of this triangle. So this is my original. So write that down, original. And you use a scale factor of 2.75. What are the lengths of the enlargement? Remember my triangle? Surface area, original, enlargement. So in order to calculate the enlargement, I'm going to multiply those two together. So, and it also says to draw the enlargement. So you're going to need a ruler. So I'm going to take my ruler and measure this. When I measure this, I get 4.7 centimeters. When I measure this, I get 3.4 centimeters. So I'm going to call this my height, and this is my base. So my enlargement base is going to be 4.7. Again, because it's on the same level, I'm multiplying times 2.75, and that was centimeters, by the way. So then I will get 12.925 centimeters, and then my height is going to be 3.4 times 2.75, and that's centimeters again. So my new height will be 9.35 centimeters. Okay, so now we're going to actually draw this. So we're going to get our ruler. I just got to drag it down. So make sure when it says to draw this, you actually draw this correctly. Okay, so meaning you need to take a ruler and actually do this. Oops. So I need to do the height first. My height is 9.35. So 9.35, 9.123, and then just a little bit. It's kind of hard on the smartboard. Okay, then I'm going to rotate this and move this over. Oops. Move this up so I can measure my base. My base is supposed to be 12.9. So I'm going to do 12. And I'm going to have to measure an additional 12.9. So there was 12. 12.9. Okay, and then to connect the dots here, or the other length, I'm going to rotate this and connect it. There we go. Okay, so this is 9.35 centimeters, and this is 12.925 centimeters. And that is enlargement.